This will be a very brief talk because I'd like to have the opportunity to have a good discussion at INLG. So this would have been nicer in person, but let's try to do this with the limitations that we have. So, large group of authors, thanks to everyone, couldn't have done it without them. And let's get started. So let's talk about errors. And first, I think it's important, and we have many discussions about this, to define what we mean by error. So an error for us is a countable instance of something that went wrong as identified from the generated text. Error analysis, and this is the focus of our paper, is the identification and categorization of errors, after which statistics about the distribution of error categories are reported. So, for example, if we have this picture of kittens in a basket, and I have a system that says chickens sitting in a basket, then that system has produced an error. We can localize the error as the subject of this sentence, namely it says chickens instead of kittens. So there's one error, and the error is this word chickens here in the sentence, and the type of error could be something like a content error or a subject error or whatever, right? Before doing an error analysis, you need to have some kind of taxonomy so that you can categorize the errors. And afterwards, you can say, okay, here's an overview of the kinds of errors that our models make. So why would you do this? Why would you not just use overall scores like the Bleu score or Meteor Rouge or some human evaluation? Well, reliable overall scores are very nice, but we believe they're too coarse-grained. So if we only have overall scores, we don't know what our models are good at or bad at. You can say, well, they're not as fluent as other models, but what does that mean? Or the overall quality is good or bad, but what does that mean? You can't really make that concrete, it's just some abstract number. It's also very hard to compare between different papers. If you only have overall scores, you don't really know how systems differ in terms of their strengths and weaknesses. So maybe two systems have the same overall performance scores, but they differ in the kinds of errors that they make. And also, if you have some overall score, that's typically an average over all the sentences that are produced by the model or all the texts that are produced by the model. And you don't necessarily know what is the worst case performance of our models. What are the kinds of errors that the system makes that are particularly terrible? So the bottom line is we need more to have some insight into what our systems are and aren't capable of. But the problem here, of course, is that error analysis is very rare. So initially we aim to write a paper sort of taking all the existing categorizations of errors and try to sort of merge them into a universal taxonomy, but that did not happen. Because when we looked at the percentage of error analyses at INLG, the percentage is really low. This graph looks like there's been impressive progress, but if you look at the graph, and this is the percentage of error analyses, then it only goes up to about 11%. And this 11% is not of all papers, it's only of the papers that we consider to be amenable to error analysis. So that features some kind of NLG system that produces some kind of output where you could feasibly analyze the errors in them. So if you look at this as a percentage of all papers, that number should be lower still. So very few papers produce an error analysis, and the big question is why. So some questions to just consider here are, why are there so few error analyses? And what are the barriers? Because if you believe them to be important, then you would expect more people to carry out an error analysis. So what are the barriers that stop people from doing this? And how can we overcome those barriers? But because I believe this is holding us back. If you don't know what systems are doing wrong, it's also very hard to improve on the systems that already exist. So potential barriers to consider. Maybe there's a lack of knowledge. People don't really know how to go about this. Or maybe they're just unfamiliar with error analyses because they rarely see them. Maybe another cause is the amount of effort that it takes, especially compared to the appreciation received for either including or not including an error analysis. Your paper still gets accepted even if you don't do an error analysis. That might be labor intensive, so why do it in the first place? Maybe it's due to the fact that there are page limits at ACL venues or venues like SIGGEN. Because we only have these papers that are 4 to 8 pages. Maybe those analyses take more time. And there might be other barriers. And one of the issues that we hope to raise is, okay, let's have a discussion about this. Let's have a discussion about the barriers that exist and what we can do about this. So in the remainder of the talk, think about this in the back of your head, and then we can have a discussion after my presentation. I'll make sure that we have plenty of time. Okay, so the barrier number 1, lack of knowledge, is something that we actively want to address in the paper. So what we've done is we've written a how-to guide on how to actually carry out an error analysis. I will not go into the details because that's not important right now. If you are interested, please do read the paper. And I'll briefly go over these steps. So first, what you need to do in an error analysis is you need to select the models that you want to evaluate and the sum or compare and the exact samples that you want to analyze. So do you just take all of the outputs, or do you take a particular sample? If you do, what kind of sample do you take of the outputs? Because that might influence the results that you get. Then it's very important to shuffle all the different outputs that you're going to analyze so that your annotators are blinded to whatever model produced these outputs. And then starts the process of annotating these errors. And this is a cyclic process initially, right? You need to try and identify errors and determine if there's no kind of categorization system already, what kinds of categories are relevant for you in the analysis of the performance of your system. There are a couple of options that I won't get into. Once you've sort of settled on these categories, you can create guidelines and examples to help you annotate these errors. And once you're sort of satisfied, you've tried this, you've piloted this approach, you can actually enlarge the sample and the annotator pool and actually start doing your real main error analysis. And you can then report all the number of different kinds of errors that appear in your output. And later on, as a follow-up step, one thing that you might want to do is try and trace back the errors to whatever caused those errors to appear in the first place. Okay, so this is mostly this flowchart that's on the slides. And really for details, there's a fairly detailed how-to in the paper. I really encourage you, if you want to do an error analysis, we hope that this is really helpful for you to get started. So some considerations behind our paper. What are the things that we discussed during this process? Well, one of the issues that we had is how to define what an error is. If we had a long discussion on the definition of errors, what counts as an error? And there are 2 ways to generally approach errors. One is looking at the source of the process. So you categorize the errors by the flaws in the data or the model. So you can say, well, this is a source error. This is a hallucination. So the model does something that I don't want. Or you can look at the product. So you categorize the end result regardless of the model. So this is a factual error. This is a number error. This is a grammatical error, etc. And we've opted for the latter to enable us to compare different approaches, because if you define your error categories in terms of some kind of model architecture, you're only going to be able to compare models that have the same architecture, and you can't compare between different kinds of architecture, say a rule-based and a neural system. So it's important to us to stress that if you want to do this, it makes a lot of sense to make your error categories as general as possible. So terms like hallucination, as I said, already hint at the process and are biased towards neural systems. You don't really hear people talking about rule-based systems that hallucinate. That term is sort of restricted to this neural literature, so that makes it suspect. Also, some other considerations are the relation between the errors in the human judgments. So some constructs in human evaluation can be expressed in terms of errors. So for example, grammaticality, you can define this in terms of the amount of grammar errors. So you don't say on a scale of 1 to 7, how grammatical is this text, but just how many errors do I see on average in this text. This is a value that's easier to compare between different papers than some human judgment, because human judges, and especially Likert scale judgments, are impossible to compare if you don't have the exact same sample, because people just have different ways of judging the same data. And also things like correctness. So how many content errors does the system make? How many things are factually wrong in the output text? So you can rate correctness on a Likert scale, or you can actually go into the text and just count the amount of errors in the text. And in future work, it might be very interesting to try and connect these error taxonomies to different dimensions of human evaluation. What kinds of qualities are we interested in as a community, and what kinds of and which of those are actually relatable to some kind of error that's identifiable in the output text. And another thing that you could do maybe is to try and predict human ratings based on errors that were annotated in the output. So maybe some errors are perceived as more or less severe, so some might not be a very big issue, others might have a very big impact on how people feel about the output that your model produces. So based on the number of errors that you find, you might actually be able to predict some kind of performance score if you wanted to. So in conclusion, and I hope this leaves plenty of time for discussion, we believe error analysis is important, and I think most of us secretly do too. But these kinds of in-depth analyses are very rare. And we, in our paper, have identified some barriers to carrying out error analysis, and we've provided a how-to guide so as to remove this knowledge barrier, so that not knowing how to carry out an error analysis is not an issue anymore. But how can we overcome the other barriers that we've identified? So things like page limits, should we expand them to include error analysis, or how can we evaluate them more? Should we maybe emphasize this more in the review process, or something? And are there more barriers? So are there other things that stop people from carrying out error analyses? And with that, I will close my presentation, and hopefully we can have a fruitful discussion here, and hopefully also in the future.
Thank you very much, Emiel. Yeah, we have 6 minutes for questions, and we already have one by Professor van Dimitra. So he asked, like, for a clarification, in your count of papers that use error analysis, what exactly did you count as an error analysis? Did you only count quantitative ones, for example?
Yes, we only counted quantitative analyses. So there has to be some formalized procedure to identify errors in the output text and to try and quantify them. We also identified in our annotation papers that include error mentions. So even mentioning what are the kinds of errors that a system makes. And those are also in the table. But I chose not to include them on the slides.
There's another question by Katsuhito. Does the amount of content errors just mean the error count, or include impacts of errors as well?
The amount, that just means the error count. So the impact of errors is a separate concept. I think that's also important. That you want to see, okay, what is the impact of the errors that I've identified? But first we need to identify what are the kinds of errors that the system makes. And you can categorize that at a more higher level, like content errors, or you can dig deeper and say this is this specific sub-kind of content error.
Then Professor Hood-Reiter coming up with an error classification which can be reliably annotated, high IAA, by non-specialists. This is not easy. Would it make sense to have a standard classification?
Yes, and this is what we initially aimed to do. But looking at the papers at INLG, we found it very difficult to do this because there are very few people that have attempted this. So it would be nice to sort of try and gather studies, and this is something that we might do in the future, gather studies that report error analyses that do provide a taxonomy and try to harmonize them so that you capture everything and all kinds of errors, and that your taxonomy is general enough to do this kind of thing.
Then Professor Albert, it seems to him sometimes that how errors are defined can be somewhat application or task specific. Do you agree? And to what extent does your proposed error identification methodology accommodate this?
So I agree that sometimes then can be application or task specific. So some kinds of errors are just not that relevant for some applications or just don't exist. So the approach that we propose is a very general one, very similar to just a regular annotation procedure. So this, I think, is a separate point from the hope or the aim to establish some kind of general taxonomy of errors in the future. I think that would be very useful, because otherwise, if people have different definitions of errors, it's still very hard to compare different papers with each other.
Then Dr. Robert by AIX Semantics, is an error perception bound to cultural backgrounds or of the reader, and how could that be worked in?
So some kinds of errors are bound to cultural background, or things like where they're very normative. So if you look at language mistakes, some things people think, oh, you ought not to say that, or you can't end a sentence with a preposition, even though that's just grammatical, right? You have this prescriptive, descriptive distinction in linguistics. Other errors, factual mistakes, are not bound to cultural background, right? Those things are just universally wrong. If the system says this presentation was held by Ehud Reiter, that would be wrong in any culture, because it wasn't Ehud Reiter giving this presentation, right? It was me in this case.
Professor Dr. Zina, your talk made me of working computer-aided language learning that has looked a lot of annotating errors in learner language. Do you think that it would be useful to look at their taxonomies?
Yes and no. So yes, it's always useful to look at what kind of work has been done in other areas. No, because learners make completely different mistakes than NLG systems, right? Learners don't do any of these hallucination or repetition things, or they produce they hardly produce any factual mistakes, because they know what's going on. It's just that it's very hard for learners to express what's going on, because they're still learning the language.
Professor Dr. Dimitra, some communities, vision and some NLP areas focus a lot on error analysis. How can we go about to learn lessons from them?
I'm not sure that we can, because they typically focus on categories that are that need to be predicted, and we focus on text that needs to be produced. And going from a category to text is quite a leap, and that makes it qualitatively different process, I think, to look at the errors and the kinds of errors that systems make. I do think it makes a lot of sense to look at how people try and trace back the sources of the errors that they perceive in the output. So if the system makes a mistake, why does it make the mistake that it does? And there's a lot of research in interpretability, and I think because NLG is just a very hard problem, because what the system produces is not a label, but really a text that's very complex in and of itself. That is something that I think is a very interesting research problem for the future.